All right. Hello and welcome to this week's lecture. We are in week 6 and today's topic is about operator overloading. As you might have noticed, I'm alone today. Alex is sick. So Alex, if you are watching the recording, get well soon. I miss you here, but I hopefully can do it also alone today. Yeah, so as I said, today's topic is about operator overloading, and we are in week 6. We only have 2 weeks left. Next week we're talking about smart pointers, and then the last lecture is about templates. But on my opinion, after today's lecture, so the most basic concept about object-oriented programming are covered. Next week, smart pointer and then templates are just additional C++ stuff, so to say. But yeah, the object-oriented part is covered after today's lecture with this operator overloading. All right, to start, as always, I have a short quiz for you. So please join our Slido quiz, and it is about exceptions, about creating own exception classes derived from the exception standard library class. And the question is, what is the output here? I know it's not that easy. I made a few pitfalls there. Let's wait until we have 40 maybe, one more. All right. So the correct answer, any ideas from your side? What would you say? The correct answer is, oh yeah, great, it's B. It's B. It's not D, it's not error, not E, and so on. It's B. Why is this the case? So we have here a function myfunc and this throws an exception. An exception of type myDerivedException, and this exception class is derived from my baseException class, and my baseException class is derived from the exception class. We have here a string containing error to create this derived class element, but this string is never used. It's just given as parameter and we never use it. And we also have not overwritten the what method of the exception class here, of the standard exception class. So this error will never be displayed. And another thing is that my derived class is also from type myBaseException. And the first catch block, which is or can be used or is of this type, is used. So in this case, my derived exception is from type my base exception, and that's why the B is printed here, and all the other catch blocks are not viewed anymore. All right, this is already, I think it was in the exams 2 years ago. So this is an exam question. It is quite hard, I know. I modified it a bit. In the exam, this arrow was not here and this constructor was not here, but the concept was the same. So we like it to give some code snippet about exception. And if you're writing the exam, I highly recommend you to have a look at this kind of code. All right, any questions to this? Great, then let's continue with our main topic today, which is operator overloading. But before, we have to discuss a few other short keywords and things that we want to use then in operator overloading. And the first one refers to name conflicts. So when we have naming conflicts, let's say we have a class cat, and this has an unsigned integer age member. And at the constructor, we are quite lazy maybe, or we haven't seen that there is already a member with this name age here. So we get a name conflict here because this parameter and the member function is the same. What are possible solutions? Any ideas what we can do here to fix this? There are, of course, many solutions. Yes? Change the name would be the most obvious one. Use our naming convention, for example, would also help in this case. Any other ideas? Yes? Great. This is the keyword I want to hear. Yeah. Another thing what I wanted to hear is use the initialization list. This would also work because it knows that this is the member and this is the argument. But the thing I wanted to know, or you said already, use a so-called this pointer. This is a keyword. Oh, this is a keyword. It's hard to differentiate now, but this is a keyword which is a pointer to the current object we are in. So in this case, we are inside the class cat, and we can write this age, and it refers to the member variable of the class. So in this case, also, we know that this type here, or this variable, is the member variable, and this age refers to the parameter here. You could also write this like this. Yeah, get complicated. Because this is a pointer to the current object, we could store that pointer in a cat pointer, which is my current cat, and then write current cat age. So this is pretty much the same. Maybe in the beginning this is a little bit more easier to get the understanding, but you can write it always like this here. So this is a pointer to the object we are currently inside. This keyword is only available inside the class, of course, because it refers to the current class. You cannot use it outside of classes because there is no context, there is no class where it can refers to. You can dereference this pointer to get the object. For example, if you want to have or want to return a reference or want to return the object itself, then you can just make star, so dereference this. And it's useful for example, resolving naming conventions and also two other things we want to have a look now, so-called method chaining, and when we want to pass the current object to other functions. It's also very interesting. So let's say we have this class. We have a player class here, and we have a team class. A team has a private member, is a vector of players, player pointers. We have an add player method, which takes a player and just pushes it in the vector. And in the player class, we have a join team method, which takes a team or a reference to a team. And here we want to add the current player we are having here to this team. So in the main function, we've created a team, we created 2 players. And then I say, okay, Walter.join team. Which team? My team. So this team I created here. And I could write this here like this as a team, so the current team. Add player, so calling this method here. And which player do I want to add? I want to add myself. So then I could use this here. So I'm currently a player, and I want to add me to a team. This is often very helpful when you have situations like this where you are in a class, in a method, and calling another class, and give yourself, your instance, your object you currently are to another class. Any questions to this? Yeah, that's a joke. Yeah. Sorry? Yes. It's pretty much the same, yeah. Any other thing? Yeah.
So the second time that you're using the class player where you do the public for join team, so is this the same class player as the one that you declared in the first line of the code?
Once again, which player do you mean now?
So in the first line you have class player.
So this one here. This is just a prototype. We have to tell the team here, the class team here, that there is a player class coming afterwards, because we are using the player class here. And when we go from top down, the compiler doesn't know that there is a player class. So we have to say or tell the compiler, there will be a player class with this line here, and we want to use it, but we implement it afterwards. That's why we tell the compiler here, there will be a player class.
If we implement it afterwards, shouldn't so the second time where you have class player, shouldn't there not be a class, or shouldn't it be just player and then the bracket? Or isn't this like a new declaration of a new class with the same name?
So you can declare it here. There is a player class, and here you create the player class. I don't know if I get the question wrong. What's the question again?
Well, because I see it like as if you have in the first line integer n, and then you say
Yeah.
integer n is equal to 5.
Yeah.
But the second one is...
So it's not a redefinition. Okay. No, this is not a redefinition of a player class. This is just like an integer n, so to say. And here we use again the player class. Yes, I get your point. But in this case, it's not a redefinition of a class. When you write it like this, it's just, you just tell the compiler there will be a class, and I will implement it later. And you always have to do it when you use the class somewhere like here before you're implementing it. So sometimes you also might face the problem in your assignments that you want to use an object from or a class where you implemented somewhere else. But you cannot include it because it can be that the other class included this class already, and it does not work in both ways. But what you can do is you can always write here the class name, and say, I will implement it later. And the compiler says, okay, I trust you. You can do it like this. Any other questions? Yes?
Could you also write, if you give two objects, then you write like this comma and this?
So you mean I could write here this, comma, and this? Yeah, but then I could do it, but I will hand over the same object twice. So this is just a pointer to the current object. And when this add player would take two players as parameters, I could write this, comma, this. But I would add then the same player twice. So we are calling here Walter, join team, and I hand over my team. So in this line of code, I will jump into this section, into this method here. And this, in this case, here is then my Walter object. And I join Walter, I add Walter to the team. And here, when I call Jesse.joinTeam, in this line of code, I'm inside of my Jesse object. And then I add Jesse to the team with this. Okay. Another thing where this is very helpful is called method chaining. So I hope all of you know this very nice koalas. And I don't know if you know it, but koalas mainly do eating and sleeping the whole day. So they eat, then they sleep for, 10 hours, then they eat, and then they sleep again for 10 hours. That's their daily routine. And we could transfer that kind of to our animal class. And this animal class has an eat method and a sleep method. Just printing is running, interesting here, yeah. Should be eating and is sleeping. And we can create animal koala and then koala eat, koala sleep, koala eat. But with method chaining, what we can do is we return always here at this object. We dereference the this to get the object and not the pointer, and return a reference to the animal. And then after each call here, after eat, after sleep, after eat, and so on, I get the same animal back. So I get the same object back and then call the next method. And this is called method chaining because, as always, I have here a method, I return here the same object, which is calling, and then it's sometimes easier to read because I know it's always my koala, and this koala is eating, is sleeping, is eating, is sleeping. Sometimes this might be a good idea, sometimes not. It depends really on the context. I would argue in C++ it's not that common, but sometimes. In Python, for example, especially when you're working with Jupyter notebooks and pandas data frames, this method chaining is very present, in my opinion. But as you can see, you can do this because this eat method here and this sleep method maybe doesn't have a return type, it's just printing something. And when I want to make it shorter, comparison to that, where I need just more lines of code, I can write it and chain these methods together. All right, so far so clear? Great. So this is then my chain of methods. Yeah. All right, another short quiz about this. So what are we doing here? We have an animal, koala, with an ID 2, and we call the constructor here, which assigns the ID with this ID. And then we call koala.getRef, so we get a reference. This, I don't know why, but it increments the ID. It returns this, so I get a reference back, and then I call ref.print. All right, let's see what you voted for. Yes, you've spotted it. Great. Most of you have spotted it. It's a compiler error. Any ideas why? Yes.
Because this wasn't the reference.
Yes. You have here, or we have here, a return this, and this is a pointer, and we are returning a reference. So what we have to do is we change, or we dereference this. This gets complicated, I know, and to get, or to be able to return a reference to this object. And when we write it like this, then the output would be free, because it's the same object we are referring here to, and it's get incremented here. All right, any questions to this? Yeah. Okay, then let me go ahead to another topic which is needed for operator overloading. We are approaching but a few slides left. And this is something which you already know about visibility, but we want to introduce you to friends also, not in real life. Would be cool that we can do it, but in C++, it turns out that there's also something like friendship of classes, and I want to show you that. So this is the visibility you already know. We have public, could be members or could be methods, private members, and also protected members. Public is, again, visible for everybody. Private is only visible inside of the class, and protected is visible inside of the class and for all the derived classes. So when you have something like this, we want to create here, again, our player. So we have our player class. A player is a name and a power. And we have here a player with a constructor, which just sets the name and the power. We create a player Harry, which has a power of 20. And we want to print the player. And of course, what's the obvious error here? Yes? Yes. So the name and the power is private. So this does not work here. We get an error because we are accessing player members which are private, and this does not work here in this case. So what we can do is we can write friend and then the prototype of our function here. And with this, it tells the class that this print player function is allowed to access all the private and protected members. So friendship in C++ means you are allowed to access private and protected members. Kind of like in real life, where you tell your friends all your secrets and the other people maybe not. So in this case, friendship means you can access the private and protected members. And yeah, so in this case, this will work. We have to define it like this. We have to write friend and then the whole prototype. So the return value, the name of the function, and all the arguments. So friends are, so if class A is a friend of class B, it's also possible to have classes and not only functions. Class A can access private and protected members of class B. We use the keyword friend for this. And it's very useful when we maybe have only one class or one function which does not really belong to a class. This print player would also belong to the class. But sometimes you might face a situation where you have a function do not really belong to a class, but you want to access the members. And in this case, you can make them friends, and this will allow you to access the private members, and all other classes and functions and so on can only access the public members. So this is just like make an exception for one function or one class. Let's have a look how it works with classes. Again, we have here our team. This is the same as before. We make a forward declaration for the class team because I don't know why. Makes no sense here anymore. Because I changed it, yeah. We have a player class with a name and a power, and we have a team again for which has a player of player pointers, which is our players. And we get here the same error in the team. We have, when we print the players, we iterate over all players, so over this vector. We want to access the name and the power, but this does not work because they are private. And again, what we can do here, we say inside the class player, you have a friend, namely the class team. So this class here, the team class, is your friend, and this class is allowed to access your private and protected members. It turns out, maybe like friendship in real life, when I tell you, or when I say I'm your friend, it doesn't really mean that you say that I'm your friend. So it's only in one way and not the other way around. When it would be the other way around, I also have to declare it here that the player is friend of the team. So with this short line of code, this again works. I can access here the name and the power of the player because they are friends now. Or the other way around, the team is a friend of the player. Any questions to this? All right, so to sum it up a bit, friend, or the keyword friend, give classes access to other functions or to other classes. And The disadvantage of friend is that it breaks the encapsulation. So we told you that you should always write your member functions private, maybe writing getter and setter. But with this friendship, you kind of break it completely, because a friend class can then again access all the private members. So this concept of data hiding is broken again, and you should avoid it. I don't know why I tell you this, but you should avoid it. But in some cases you might need it. We will come to that at the next topic, at operator overloading. But in general, please do not make every class friend with every other class. That's kind of like the same when you're writing all the member functions public. So use this in very, very special cases if there is no other way around. But for the assignment, so to say, maybe you have 1 or 2 friend classes all together. So maybe one class is a friend of another one, but it shouldn't be that 5 classes are friends. That's way too much. And friendship, as at least in C++, is not transitive, meaning that if class A is friend of class B, then class B is not always a friend of class A. Yes, so now we have done our work, or dirty work. We know now this, and we know friend. And now we come to operator overloading, the interesting part of today, in my opinion. So, before we go into the topic, this is a very easy example. Class player, again, with a constructor, we are creating George and Fred, having a power of 10 and 14. And in this line of code, I want to calculate the power of Fred and George. And here it should be combined power, sorry for that, but I want to then just print it out. What we normally do is we create a function, add power, which takes 2 players, and then we calculate a.getPower plus b.getPower. This works perfectly. But it would be better, cooler, easier, I don't know, if we could write it George plus Fred. So it would be easier, it would save us from writing our own print or add power function here. When we could write George plus Fred, we get back the combined power and we can print it. Wouldn't that be cool? And this is then already operator overloading. So what we can do here is, we have George, we have Fred, and we have this plus operator. And we say this plus operator here has a specific behavior we want to define now. And we can define it inside the player class with this, let's call it special method. It's just a method inside the class with the keyword operator plus. So we are modifying this plus operator here. And it takes another player. I will explain it in more detail in the next slide what this means. And it returns the power of this player and the other player. So it returns an integer. So I will get my combined power back. This already works. And it depends on the context, but it might be easier to read and might be easier to understand in some cases. Okay, I know you cannot understand this completely now, but the next slides hopefully will cover all this. So in general, operator overloading can be used to modify behavior of operators, that we have seen now in one example. And these are all examples here, example operators we could modify. I will show you afterwards a few funny and awkward styles or stuff, how people modify operators. It's sometimes too much, in my opinion, but you could override, for example, the logical or the logical and, or the less than, or the assignment operator, or the dereferencing operator. So you can add your own behavior however you like it. It's possible for your own user-defined classes, like we have here. So George and Fred are from type player, and we defined this type. It's not possible for character int and float, because we cannot override them. They are already somewhere in the library, and we cannot modify this. But for our user-defined classes, we can set our own behavior for these operators. Okay, so I think this is now the most important concept, so please listen now. We have this easy and short equation, let's call it equation. We have George plus Fred. And we have an operator. This is the plus symbol. The left side here is object of type player, and it's often referred to the left-hand side, and many people then write it like LHS. And this side, so the Fred, is also an object of type player. It's the right-hand side of the plus operator. It's not that complicated. So this is the left-hand side, this is the right-hand side. So this is an operator which has two sides, the left side and the right side. Keep that in mind for later. And in general, when we define operator overloading, we say, like a normal method, a return type, the function name or the method name is always operator, and then the symbol we want to, or the operand we want, or the operator we want to override, and then possible arguments depending on the operator. So some operators need arguments, some don't. We will come to that in a few slides. And then you can implement here whatever you want. It's not bound to what is logical. Theoretically, you could write there whatever you want. So, for example, you could override the plus symbol and subtract something. Doesn't really make sense, but you can do it. So again, we have here this operator plus, and we call George plus Fred. So as I said, this one here is of type player, and this here, so the left side is always the side which is calling the operator. This operator here is inside a class. It's inside the player class, and we can write this power, and we refer to the keyword this, and we know that this is always George, because George is on the left side. This is the operator we want to overload. In this case, it's the plus symbol. The right side of the operator is then always the argument here. So in this case, the argument here is Fred. And what we can do now is, okay, we add the power of George plus the power of, in this case, Fred. This is just a number, and we return then, so the return type is integer, return then an integer. So the result of this equation here of George plus Fred is an integer, and we can store this value then in a variable. Is that clear? So are there any questions to this? Because this is very important to know or to get an understanding how this in general work. When you call operators, it's always called on the left side. So inside the class, you can access the left side of the equation with this, and the right side is always in the arguments. Any questions to this? Yes?
Is it also possible to add 3 different members of the class?
Not really, because when you have George plus Fred plus Harry, there's always one equation which is calculated first, and then the third is added. So the return type of this is an integer, and when we write here plus something else, we calculate an integer plus a player. And this could also work, but we have to override another operator which then works for a player. The player on the one side, and on the other side, we have to take an integer. So when we have George plus Fred plus another player, maybe this one is calculated first, the result is an integer, and this integer result is then added to a player, which generally is not working, but we could override it again, that integer and player has some specific behavior, and then it would work. So you are pretty free you're very free in the return type here. We could also say, and we will come to that, we could also say that when we adding 2 players, a player can come back, maybe another player. We will come to that. Any other questions? Yeah.
So theoretically, we could override the equal symbol to copy the layer. So instead of writing.
Yes, we will also come to that. The assignment operator, in general, the assignment operator is already overwritten. So every class internally has the assignment operator overwritten already. But you can also say, okay, I want to override the assignment operator again and do some specific behavior there. This works, but we will cover that in a few slides also. Yes?
You also said we could chain it, and then we would have to override how an integer interacts with a player.
Yes?
But wouldn't that be changing how the operator plus works for an integer, or is that still allowed?
It depends. You cannot modify the integer operator on the left side, but you can modify the player operator on the left side plus an integer. This would work. But when you have, left side, right side, and this is a player, this is an integer would work, this is an integer, and this is a player would not work. Any other questions? Maybe a few examples would make it also more clearer here. So as I said before, we are not bound to having here an integer return type. We could also say when we add George and Fred, we want to create a new player with the combined power of both. So we say the return type is now a player pointer, and from George, so this is George, power plus the right-hand side power, in this case Fred. We combine this, we get a power, and then we create a new player with a specific power, and we call this run. And when we say run get power, it is the combination of Fred and George in this case. So when we do it like this, and we want to have an integer back, but it returns a player, again, the compiler will say this does not work because you were expecting here a player back, but you take here an integer. So if you would write here an integer, but having this operator overloading, this would not work again. But what we could do is we can combine it. We can write this operator here returning an integer, and we could also have another operator returning a player. All right, so the output here, as I said, is then a new player which is returned here. But of course, as you can see here, we are creating here a new player on the heap. So we have to deal with that also, and we have to delete it afterwards. And what you also could maybe, or what could make it more easier for you, so when we write George plus Fred, it's the same like you're writing George dot, so you're calling the method of this object, operator plus Fred. So you're calling this method here. This is just a normal method of the class player, which has a pretty interesting function name, yeah, but the function name is just operator plus, and you can call it like this and hand over another player in this case. So in this case, we expecting to be a player reference, so we hand over the player here. So this is pretty much the same, but this is again harder to read, and that's why most of the time you will write this, because this is the great benefit of operator overloading. We already used operator overloading, and I think you also used it. When we did something like this, we have created a few strings and we concatenate them. So we have this OOP string, we say plus OOP string is plus whatever you want to write here, it's up to you. And what internally is implemented is that inside the string implementation, it's much more simplified, but there is an operator plus, which takes another string and it creates a new string and just appends the string. So it's called on this string here. So this is the left side. And this is the right side first. And this right side here is just appended on the new string and returned. So the result of this operation here is OOP is. And then the next step, we add OOP is. So this is our left operand. And this is then our right operand of this plus. And what we do here again is we take the right operand and append it again and return it. And this is again like a bit of method chaining. So you return here a string from type std string, and then you can concatenate and add more strings together. So internally, when you use this plus symbol, luckily we can do it in C++. In C doesn't work, but in C++ we can do something like this because internally the operator plus is overloaded and it just appends to the string. Okay, then maybe the question occurs, which operators can be overloaded? And there are many operators. Arithmetic operators like plus or the plus, the add symbol, the equal symbol, the greater than, lower than, of course, all the relational operators. This is just these are just few examples here. Logical operators can be overloaded. Bitwise operators can be overloaded. Assignment operators or add and assign operators. We could also overload dereference operators, address of operators, bit shift operators, and so on. On my perspective, in most of the cases, it makes sense for maybe arithmetic operators, the plus, sometimes maybe the equal would also make it, when I say is the player A equal to player B, would also make sense. I've never used something like a bitwise operator. Logical operator would also make sense. Bitwise operator does not really make sense. So I have haven't had a use case where I override a bitwise operator and also a dereferencing on address or a bit shift operator. This is, so the use cases are very small in my opinion for that. But what's important is that there are two types of operators. And we always talked about this kind of operators where we have a left side and a right side. But there are also unary operators which just have one side, so to say. We just have like the left operand and no right operand. So the syntax for binary operators, as we have seen now, is always we have a class, we have this operator plus, and we have a right-hand side. What we do here and what's the return type is up to us, but this is just an example. So the object here, the left side, calling the operator method inside, and the right-hand side is then the object which is inside here. The multiply operator works completely the same, just the difference that there is a star symbol here. So this is what we want to override. And of course, we could also then multiply inside. We could also use plus here, and all our users would be furious because when they use George times Fred, it will only be added and not multiplied. So what you write here inside is pretty much up to you. So these are binary operators. This is pretty much the same as we have seen now. But at unary operators, there's one difference. There's just one object here. So in this case, we could write plus plus George. So the pre-increment operator, like you know from I++ or whatever. And what we could do here is, for example, increment the power then. So when we write it like this, we could increment the power then. And as you might have noticed, that we do not have a right side, so there is just no argument here. But it works pretty much the same. When we had the post-increment operator, so the George++, it's pretty much the same operator overloading. There's just one difference. You write here just int as an argument. But it's the same. In this case, we return void. So nothing. We could also return, for example, the player. We could also return, for example, an integer. It's up to you what you want to return in this case. So the dereference operator, another operator, we could override. In this case, it doesn't really use or make something interesting. It just returns, maybe this is a member variable here, a pointer. But as I said, the right-hand side of these unary operators is missing because they are unary. There's just one object applied to it. All right, a short quiz again. Which operator overloading method will be called here in this case? So we have a player George and a player Fred. And we say if George is equal to Fred, then Cout equal. Of course, you can say that this is std out, so this is correct here. This is not a compiler error. Okay, let's have a look what you've voted for. Wow, great. So we have operator equal. We most likely want to return a Boolean variable because this should be true or false here. And the right-hand side is a player because the Fred here is a player. So yeah, great. Looks good. Perfect. We have now two operators left which are kind of special, so to say. So one is the output operator or the stream operator or just this less than sign. So sometimes we want to say, okay, we create our player George and we want to give it out, to print it using std out. And of course we could write George print. We could write there a method inside of the player. But maybe we also want to do it like this and just say, okay, we want to print George here. Then we get this kind of error message. This is truncated, so this is twice, or I don't know, it's much longer. I had the font size 2 already and it doesn't fit on the screen, so this is a very, very hard to read error message. But essentially what it's saying that you cannot pass a player into Cout. Yeah, sure. The compiler doesn't know what to do now. So how can we override this? Our left operand of this operator here is std out, and we cannot modify this method from this library because we cannot modify the library. The right operand is our player, so this would be no problem here. But what we can do is we have a main function, we have our player class, and we say, okay, we write this operator outside of the player, and we take, I know it looks ugly, but we take 2 arguments now. The first one is kind of the left side, which is our stream, our std out. And the right side is our player, a reference to the player. And what we can do is we can here then modify and write into our stream, into our out stream, let's say power and then p.power. Looks good. Any ideas if this works? What would you say? Or do you spot any errors here? He was a bit faster, sorry, yes? Power is private, great, yeah. So the power here is private, this does not work. You should always return here this the stream again, and the return value should be the stream, because you maybe want to chain it and say STDC out, George, and then maybe an end line and so on. So the return value should also be always a stream. But you're right. The power here is private. Any ideas how to fix this? We've heard something today. Yes? Friendship, yeah. So what we can do is we say we add this function, it's pretty much just a function, this operator as a friend of the class, and then we can access this. Another solution would be that we, pretty much implement it again inside the player. So in this case, we have written it outside of the player class, and here we can just pass it into the player class and say, okay, we have a left side and a right side, and this is a friend which is included in the player. This would also work. But I would prefer this solution because it's a little bit more clean, in my opinion, because this operator does not really belong to the player class. It uses a player, yes, but it kind of breaks a bit the rule that you should only include operators inside of the class which are on the left side of your operation. So I would prefer this, where you just declare it as friend and say it's somewhere else implemented, and you can implement it maybe above or below of the class. But it's up to you how you handle this. All right, let's go a little bit back in time. In lecture 3, we had this problem. I know we are jumping now to a little bit different type of class. We had this time, Alex talked about this time class where we have an hour and a minute. We have a copy constructor, a normal constructor, and a sync time method. And he told us, okay, in this case, the default constructor is called. In this case, the copy constructor is called. In this case, again, the copy constructor is called. In this case, again, the copy constructor is called, and so on. We talked about this in lecture 3. But in this case, none of the above is called, and it was kind of a cliffhanger back in the day from him. And any ideas what is called in this case? So it's not the copy constructor. Yes? Yes. So I refer it now to as the assignment operator. It is pretty much the same. So the only difference here is, so when we look at this line of code here, the left side of the equal sign is new. So we are currently creating it, and this exists. And in this line, both, so the left and the right side currently exist. And if this is the case, so if in this case T3 and T2 already exist, the assignment operator is called. So we could implement this also here. We create the operator which takes a right side, a right-hand side, in this case then this T2, and we can write whatever we want here inside and return then dereference this pointer, so the object, and we return the reference to it. So then all the stuff which is inside of this D2 gets written into D3 because this operator here is called. Sometimes it's a bit hard to think and to which one should I choose now, or sometimes you make mistakes or use this assignment or you use this assignment operator but wanted to use the copy constructor. So my tip or my hint is, and what you also should do if you do not explicitly use the assignment operator, you can write is equal to delete, which means that something like this would not be possible anymore. Then you get a compiler error. But sometimes it's better to delete the assignment operator if you don't use it, because it reduces the risk that you use this by mistake, like here. So sometimes you think, okay, this is just a copy constructor, it works, but then you realize, it's the assignment operator, so I have to delete it. You can also delete the copy constructor if you don't need it. It helps you to avoid this kind of mistakes. Any questions to this? Yes?
So in this situation, the operator, so the last function that we have, that you deleted, is not a copy constructor, it's not any constructor at all, but it's defined as a constructor with time in the hours.
This one here. This is not a constructor. This is an operator overloading of the equal sign operator. It's not really a constructor. This is a constructor, this is a copy constructor, but this is the assignment operator, which is overwritten, or in this case, deleted. It doesn't really belong to constructors.
Because in the previous slides, when we define some operator, for example, the first time you wrote int operator plus, and because it doesn't have a return back.
Yeah.
We don't return anything. In this situation, we also don't return anything. We just do something.
We could also write here void, for example. This, or maybe this might make sense. We could also write here void, and this would also work here because it writes the content of T2 inside T3, so inside this object. But in most of the cases, when you have an assignment, you can try it on your own. When you write something like, I don't know, when you write 1 plus 1, the output of this is 2, obviously, yeah. But when you have an object, or when you have like an assignment, when you have 1, this doesn't make sense, sorry. When you have I is equal to 2, yeah, and you can store the result maybe in another variable j. The result of this would be also 2. So it makes sense that if you have an assignment, this is just an assignment, when you have an assignment, to return or also the result. As I said, when you have I assigned 2, so the value 2 is assigned to I now has the value 2, and also the result of this whole equation is also 2. You can try it out on your own, and this is why most of the time you should return also the class here, but you could also just use void. Hard here to write, and this would work, yeah. But then the return of this, so when we want to, I don't know, say T1 is equal to the result, so the result of this, then T1 is just nothing. When you have here no return value. Does this make sense? Is this also the answer of your question? Okay, great. Any other questions? I hope I can delete what I've done here. Yes, great. Any other questions? Great. Okay, I think that's the last one. And please just mark the correct statements of today's class. So, kind of a summarization of today, we have mostly have talked about operator overloading, about this, and about friends. What do you think are correct statements here? Okay, let's start with the first one. The assignment operator is implemented for classes by default. That's true. No, it's okay. The ordering is different now. Let's start from the top. There are operator overloading functions that take 2 arguments. Yes, we have seen one, so the output operator, for example. Inside the operator or the overloading function, this is always the left operand. It's also true. The return value of an operator can be void. Yes, the assignment operator is implemented for classes by default. Yes. And now coming to the statements which are wrong. Friend allows us to override private operators. The keyword here is operators, and there are, or friendship does not allow to override private operators, but private methods or private members, for example. This can only be used inside of functions. This is wrong. Yeah, I don't know why I marked this as correct. This is wrong. It could only be used inside of classes, of course. And unary operators have a left and a right side. This is wrong because it only has a left side, only one operand. Yes? Yes, but in a stream operand, there is no this. So when this is available, then it's always the left side. Yeah, I have to maybe specify it more clearly. Thanks, yeah. Yes?
But couldn't, for example, also exist a private operator overloading function that only exists within a class and not outside the class or public, so that friend allows us to override private operators would also be true?
To override private operators. So you mean when you declare an operator overloading in the private section? Let's try it. Do we have something similar here? We have here an operator. And okay, this is even harder then. So this would be inaccessible in general, yes. You're right. When I declare it then as friend, it would be possible. Yeah, that's true. Well spotted. Thank you. All right, so I promised you to tell you a bit of funny operator overloadings in the end. As I said, almost all operators can be overloaded, except a few, which are the scope operator, the pointer operator. So when you declare a pointer, this is not possible. The dot operator and the ternary operator, where you have this question mark and this, What you could override is new and delete, for example. So the keywords new and delete are overwritable, so to say. So for example, you can modify the behavior of new and delete. I don't know when this makes sense. Maybe when you have a class and inside the class there is, I don't know, a vector which again needs memory or whatever, or another object which needs memory, and you just want to create the class, and in the new function or in the new allocation, you can allocate memory for your class and for the subclass which is included. Maybe this would work. Another thing what you can override is the array access. I don't know when this would be a good idea, but maybe. And funny thing, you can also override function calls. So you can do something like this. We have here an adder class, just adding to a function, or adding to integers. We create here an object adder, and we call here this function call. So we override here this parenthesis, and we call the object with this function kind of call and add this and get the result back. Kind of odd, never used that. I also wouldn't recommend it because it's harder to read than normal calculation, in my opinion. But there are funny people who try to make the most interesting and most funny operator overloadings. I saw one from a mathematician where we have this this logical OR sign, which are just two straight lines, and he overloaded it when the left side and the right side are parallel to each other. So the left side and the right side are objects, which are lines. I don't know what kind of object, and he overrided it that this logical OR means that they are parallel to each other. Yeah, you have to know this then. Okay, so to conclude, overall, operator overloading changes the behavior of operators. Most operators can be overloaded. There is a list of operators included here. We can open it for short, and you can see here, for example, the new and the delete can be overloaded. So there are many operators you can overload. Some operators are overloaded by default, for example, the assignment operator, but you can overload it again or delete it. And it's only possible for user-defined classes, as we have seen, character, integer, whatever, is not possible to override, at least on the left side. And the implementation varies a bit depending on the operator. So for unary and for binary operators, we have this argument at the binary operators, and for the unary operators, there are no parameters. For the output operator, there are two arguments. And for the assignment operator, you have to consider maybe to implement also a deep copy, because it might be that there is memory inside of the object, and you want to ensure that this is also copied. So assignment operator should implement deep copy if needed. And in general, I would say that you can use operator overloading, and you also get points for operator overloading in assignment 2, but use it only when it makes sense. So when I see operator overloading in your code, and I have to see at the class what this operator overloading means, it kind of fails the concept, because it should be self-explained. So only use it when it's straightforward to understand, maybe when adding two objects or whatever, like in the string we have seen, we can add two strings and they are concatenated. This totally makes sense, but in some cases it does not really make sense. So also for your assignment, please use it only when it makes sense. Yeah, I think in the assignment interviews, the tutor will ask you about what you have done for operator overloading. I don't know exactly. I think you get 3 points for operator overloading. It is stated in our course website. So when you do operator overloading, just tell your tutor and you will get extra points for that. All right. I think that was it from my side. Then have a nice day and goodbye.